Second Srinivas.
Yeah, okay. Allow me to share screen.
Okay.
So hi friends, good evening. So welcome to the Automotive Analytics training by 360DigiTMG. So successfully we have finished the 2 classes. So in the first class, we discussed about the applications of automotive analytics, where we are using this automotive analytics. And we discussed it is very important step for different phases, and it is very important in the supply chain management. And I have explained the use case, the importance. So importance regarding predicting whether the motor is going to fail or not, so that suitable measurements we can take. So these things we discussed in our first class, and yesterday discussed about what is machine learning. So machine learning is nothing but, so by the data and algorithm, machine can learn how we are learning, how humans are learning. And so even we have the machine learning concept, but organizations are need complete guidance for developing machine learning applications. So they propose it one methodology, that is nothing but CRISP-MLQ, cross industry standard process for the development of machine learning applications with quality assurance methodology. So in this we have 6 phases. So first one is nothing but business and data understanding. Second one is data engineering. Third one, model building. Fourth one is evaluation. Fifth one is deployment. Sixth one is monitoring and maintenance. So these are the 6 phases. Now, if you consider any business problem, so any business problem with respect to this automotive industry, you can take any problem like how to control CO2. So generally vehicles will release carbon dioxide. How to minimize that is a problem. Then what is the business? We have the data, and after we need to note down the objectives and constraints. So we need to implement. So we should collect the data. If we not have, then we need to clean the data. Model building. Model building is nothing but it is we can build based on the knowledge on machine learning models. So we discussed already yesterday. So machine learning is briefly classified into 4 types like supervised learning, unsupervised learning, reinforcement learning, and semi-supervised learning. So supervised learning is nothing but if we have the output variable, if we have the labeled data, such learning is nothing but supervised learning. If there is no output variable, then that is nothing but unsupervised learning. Similarly, semi-supervised, combination of supervised and unsupervised. So reinforcement learning, gaming application, by in which what steps are leads to increasing the scores. Like now today we will discuss the important step in CRISP-MLQ, that is data engineering, second step. So after business and data understanding. So in this data engineering, we can say also cleaning of the data. 2 things will be involved, that is exploratory data analysis and data pre-processing. So anyway, it is very important in machine learning. So that's why I'm going to explain why it is important and what we will study in EDA and data pre-processing. Yeah. So coming to agenda, so today we will start with various data types. So then we'll discuss about the measures of central tendencies. Then we'll discuss about measures of dispersion. And finally, data pre-processing. So let us start with data types. So data types. So data is nothing but information. Data types are nothing but classification of the knowledge items. Now, generally we have the continuous data and discrete data. So if you see the time, so time comes under continuous data. Money, so continuous. So measurement of length, we can say continuous. And we cannot say 1.5 computers, 1.5 laptops, 2.5 laptops. So computer or laptop is discrete. Car also comes under discrete because we cannot say 1.5 car, 2.5 car. So next, measures of central tendency. It is also called as first movement business decision. So where we will mainly focus on, so mean, median, mode. So let us briefly understand what is mean. Mean is nothing but sum of observations by total number of observations. Suppose if the observations are like 1, 2, 3, 4. So this mean is nothing but average, sum by total. So total observations will be added by the total number of observations, mean. So for population parameter, this is a formula, mu is equal to sigma xi by n, and for sample statistics, sigma xi by small n. And median is nothing but middlemost value of a data. And mode is nothing but most repeated value of the data set. So in our analytics, so we may sometimes we use mean, sometimes we use median and mode. So when we have outliers are nothing but extreme values. We discuss it. Suppose the data points are like this. So 1, 2, 3, 4. So another data point is nothing but 1000. So this is the data point is very different from the existing the remaining data points. So we can say it is outliers. So outliers are happening just due to some manually, or sometimes values are added. So if we calculate mean, so definitely it will show effect. So if you find the mean for this 1, 2, 3, 4,000, and the value is not with respect to 1, not with respect to 2, 3, 4. So in that cases, we go with median. Okay. So mean is anyway, mean is nothing but total, mean also called as average. Average is equal to sum by total. Median is nothing but middlemost value of the data set. If we have the various data points, then we can get right into the ascending order, then the most middle value we can take as median. And mode is nothing but most repeated value of the data set. So this is about first movement relation, measures of central tendency. So next, let us discuss about measures of dispersion. So measures of dispersion, it is also nothing but second movement business decision. So here we will speak about variance, standard deviation, range. So variance is nothing but how the values are different from the mean. So x is the value and mu is nothing but the mean. How the values are different from the mean. So for population sample statistics, formulas already given, and standard deviation is nothing but square root of the variance. Square root of variance will give standard deviation. Range is nothing but maximum value minus minimum value. Next, we will do everything in hands-on, don't worry. Next, data pre-processing. So data pre-processing is a process of preparing the raw data and making it suitable for machine learning model. We need to process the data for suitable for machine learning model. Next is a crucial step because if we not process the data well, a machine can predict wrong values. And when creating machine learning project, it is not always the case that we come across clean formatted data, because as we are a machine learning engineers, we should not expect we have the data with clean, should not think. So we will get the data. Lot of cleaning technology should be implemented. So before going to the model building stage, and while doing any operation with the data, it is mandatory to clean it and put it in a formatted way. So for this, we use a data pre-processing task. And why do we need data pre-processing? So a real world data generally contains noises. Noises is nothing but if you have the data, the values are not with respect to the data set. So very different, unknown values. Noise is nothing but completely unrelated from the existing data, and missing values. Okay. So if there is a data set and no values will be, so that is a missingness. So if there is a missing values, so definitely machine it is a very difficult to process, and maybe an unusable format which cannot be directly used for machine learning model. These are the three challenges we have. So if we have such type of things like noise data and missing values and unusable format, very difficult for a machine to understand. So that's why data pre-processing very important, and it requires tasks like cleaning the data and making suitable for machine learning model. And also the advantage of this pre-processing is it can increase accuracy and efficiency of machine learning model. So let us discuss what are the steps involved in data pre-processing. So first we will getting into the data set. Then after getting the data set, just we need to import the required libraries. Then data set and finding the missing data, and if we have the categorical values, so then we can convert into the numerical form, and finally we can split the data into training and test, feature scaling. So feature scaling, yeah. So it is a method used to normalize the range of independent variables of features, of normalizing the values. So feature scaling. So these are the things are very important. Yeah. So let us go with try to understand more by going through hands-on. Yeah. So I have taken one data set. So basic EDA of CO2 emissions by vehicles data set. So I have the data set. So in the data set consisting of the columns, so which are the features related to the emissions of CO2, carbon dioxide. Anyway, carbon dioxide is very harmful to the environment. Now let us apply ED and pre-processing techniques for this data set. So before going to the first, so objective of EDA is nothing but to check for missing data and other anomalies. Any abnormalities are found or any missing data we have. These are the next to gain maximum insight into the data set and its underlying structure, to check the distribution, how the data is distributed, and identify the most influential variables. So these things we can understand by doing ED. Fine. Next, importing all the required libraries. Yes, so we need to import pandas as PD. So pandas is working. Pandas must for analyzing the data, and NumPy for arrays, and these are the different libraries so which we need to analyze our data. So just I am executing and type stars cube matplotlib.pyplot for visualization, etc. So let us execute this. So next, importing and reading the CSV file. So just I have got the data from the Kaggle and just I can execute, taking the file, and I'm loading that file, CO2 emissions in Canada. Now I'm checking for the information regarding the data set. So like fuel underscore con dot head. So fuel underscore dot con. So that is the name I have given for my data set, and dot head gives the top 5 rows in the data. So let us execute this. Yeah. So which type of make, model, vehicle class, engine size, cylinders, transmission, fuel type, etc. So these are the various columns. Yeah. So fuel underscore con dot head gives the top 5 rows. Next, to check the detailed information of each feature, just we need to fuel underscore dot con info. So info will give the detailed information regarding our data set. So now data set consisting of various columns, make, model, vehicle class, and data types also you can able to see. Next, what is the shape of our data set? If you execute this, yeah, this data set has 7,385 rows and 12 columns. So to check the column names, so we need to specify fuel underscore con dot columns. So we'll give the column names. Yes. And first step is to check for null values. Do we have any NA values? So if you have the NA values, the sum of NA values in the particular column we will get. So let us execute. Yes. So in our columns, make, model, vehicle class, engine size, cylinders, transmission, everything. So now you did not find any NA value in that column. So it is fine. So some inserts also I have given here. So there are total 7,385 rows or samples and 12 columns. So 11 of the features are predictor, 1 is regression. So here the output, anyway, we will discuss the machine learning implementation. It is comes under supervisor and a regression problem. So today, anyway, we'll discuss about ED and pre-processing. And here the predictors are nothing but independent variables. So the output is depending on these 11 predictors. And 5 of the 12 column are object data type, 3 integer, 4 are float type. And anyway, so we can see there are total 7 columns with numerical values and other have categorical values. And the columns engine size, cylinder, fuel consumption city, and fuel consumption comb, yeah, comb. These are some and numerical noun or nature. And the columns make, model, vehicle class, transmission, and fuel types are categorical in nature. Fine. So let us analyzing the categorical values first. So how many unique values are present with respect to that make? So make column, so total 42. So total number of unique is 42. The things are like this. And similarly, how many unique values are? So 2053. Similarly, vehicle class 16. Yeah. So what are the different vehicle classes are given here? Transmission 27. Yes. Now next step is mapping similar labels into single label for transmission column. So the transmission different things are there. So we can make into the same. Done. Now transmission, so it becomes less. Fuel type, yeah. So this will give, if we make into some categories, it is easy for analyze. So next thing is changing the labels into the meaningful labels, like fuel type, Z, premium gasoline, regular gasoline, diesel, etc. Yeah. So we have the fuel type as now either premium gasoline, diesel, regular gasoline, ethanol, natural gas, etc. Next, now I am checking the top 5 rows. So these are the top 5 rows. So make, model, vehicle class, cylinders, etc. Now some insights from the data. So there are total 42 types of car brand, and there are total 2053 unique car models. So it is neither can be converted. Unique 2053 unique car models we have. Suppose if you try to convert into the dummy variables, yeah, it is very difficult. So these neither can be converted into any dummy variables, nor it can be used for analysis. So there is no scope for analysis. So we can drop this column. Similarly, there are 16 types of vehicle class basis on their gross vehicle weight rating and volume index. So, but there is no data available with exact the values. So we can categorize the similar vehicle into the same group. And the 27 type of transmission has been clubbed into the 5 transmission. So if the total 27 types, again it is very difficult. So without taking the number of clutches into account, as it does not affect CO2 emission. And the 5 types of fuel types have been renamed so that it becomes more meaningful interpretation, like methanol, natural gas, like that. So frequency distribution of different categorical variables. Yeah. So let us execute. Feature is nothing but make. Yeah. So this is a frequency distribution of feature make. How make is distributed. Okay, you can see the Ford, BMW, the values with respect to the brand name. Next feature. So model. So working with only top 20 models. So let us execute. Yeah. So you can see here. So frequency distribution of feature car models top 20 plot. So top 20. So various names of the car models. Next. Third feature is nothing but vehicle class. So let us execute this. Vehicle class. So frequency distribution of the feature vehicle class. Yes. So next one is transmission. So automatic with select shift, etc. So transmission types. And fifth feature is regarding fuel type. So regular gasoline, premier gasoline, ethanol, diesel, natural gas. Now from this we can find some insights, like out of 42 car brands. So these are one with lowest frequency, and vehicles are most frequent ones on Canadian roads. And frequency of the car with the transmission type automatic with the select shift is the highest, and with continuous variable. And transmission 576 is the lowest, and car which runs on gasoline, let it be regular. Petroleum is the most common vehicle type. And cars running on diesel are very low in frequency. There is only one sample which uses natural gas. So these are some insights from that analysis. So now variation CO2 emissions with different features. So how CO2 is changing. So with respect to different features. Yeah. So CO2 emissions, if you observe this graph, CO2 emissions variations with brand. So brand with respect to emissions. So first one is smart less, and if you see at last one, we can able to see the more emission. So the relationship between the brand and emission. First are releasing less, and the last ones are releasing more CO2. Similarly, let us execute this. So you can see the distribution of CO2 emissions in relation to make. So CO2 emission with respect to make. Now the insights from the above graphs, from both the bar graph and box plot, it can be inferred the average CO2 emissions of the cars belonging to the brand Bugatti is the highest, and car smart has lowest emission. So it is clear already. And the red line signify the sample mean of CO2 emissions. Almost, so 50% of the brand has their median CO2 emission less than sample mean of CO2 emissions by all the cars. Right. So next, let us discuss about vehicle class. Yeah, done. Now CO2 emissions with vehicle class. So how the CO2 emissions are depending with respect to the vehicle class. So I think we cannot observe the more difference with respect to the vehicle class. Now let us execute this vehicle class with respect to emissions. From last two, so it is clear that the vehicle of class van passenger followed by van cargo has the highest CO2 emissions among all, and station wagon small has the lowest CO2 emissions. So which one is giving more emissions, which one less given? And there are 8 types of vehicle class out of 16 which have a median of CO2 emissions. So less than sample median of CO2 emissions, and the other 8 has higher median. Yes. So next, with respect to the transmission. Yeah. So transmission versus CO2 emissions. So from this it is clear. So vehicle with automatic transmission exhibit the highest CO2 emissions, and the vehicle with continuously variable transmission shows the lowest CO2 emissions. And median CO2 emissions of automated, same thing happened. Next feature with respect to fuel type. Now what we are doing is, so we are checking each and every column, so with respect to the CO2 emissions. Let us execute this. So fuel type, like natural gas, regular gasoline, diesel, premium gasoline, and finally ethanol. So ethanol and premium gasoline, so both has highest values, so with respect to CO2 emissions. So let us execute this. The distribution of CO2 emissions, so in relation with respect to the fuel type. And from this we can have some analysis, like the cars running on ethanol has the highest CO2 emissions, with almost all the values are higher than the sample median CO2. And natural gas has the lowest CO2 emission. Yeah, but there is only one vehicle that use it as fuel. So other than regular gasoline has the highest, lowest CO2 emissions, with almost 70% of values less than sample median. And the median CO2 emissions of fuel type premium gasoline and diesel has almost similar median. Now analyzing the numerical values. So let us do some descriptive statistics. So descriptive statistics. So we have mean 25 percentile value, median 75 percentile, standard deviation, skewness, mean value, maximum value. So this describe is applied on numerical values. So you can see the numerical analysis, statistical analysis on the features. So the insights from that above. So the range of our target CO2 emissions is between 96 to 522, and mean CO2 emissions are 250.58 and median is 246. And 25% of sample points has CO2 emissions within 208 and 75% within 288. And all features are positively skewed, significantly more skewed than this. Okay, these are all some analysis with respect to above steps. Now to check the shape of the distributed and skewness of each feature. So let us execute. So this is the distribution and skewness of each feature. And from this we can find the cylinder feature has discrete values. So it is the most positively skewed distribution. And to visualize the distribution of the dependent variables using frequency distribution box plot, let us execute this. Yes. So CO2 emissions, so value distribution and frequency distribution. So from the above box plot, so we can infer the following things. The minimum value of CO2 is around 96. The median CO2 emissions 246, and 25 percentile of the samples have CO2 emissions between 96 to 208, and 75% 96 to 288. No outliers. So maximum CO2 emissions observed is 522, and distribution of CO2 emissions are positively skewed. So these are the insights from the above. So correlation matrix, the relationship between columns. Yeah. So here you can able to see how the each and every column is related with respect to each other. So 0.9, yeah. One, both are set. Yeah, you can find the difference. This is the relation between each and every feature. And from that we have some insights like fuel consumption is negatively correlated to all the features, and all features are positively correlated with each other. And so fuel consumption, since fuel consumption is redundant. Okay. So next, correlation of independent features with dependent variable. So let us execute this. Yeah. So correlation of independent features with dependent variable. Now variation of CO2 emissions with different features. And fuel consumption with the number of cylinders. Finally, let us execute this. Yeah. So distribution of CO2 emissions in relation to the number of cylinders. So from this, increase in number of cylinders, CO2 emissions also increase. And the same time to consumption emissions. And vehicles with less than 6 cylinders have almost all the sample with median CO2 emissions, and vehicle with more 5 cylinders almost 100% sample. Okay, so these are the insights from the above. And feature engine size. So CO2 emissions with the engine size. And fuel consumption with engine size. Engine. So here the emission relating with respect to each and every feature we are discussing. Size more than 2.5 liter has median CO2 emissions. Next, fuel consumption city. Heavy. And fuel consumption. So CO2 emissions with the fuel consumption. You can see here. Continuously it is increasing. You can note down that. So with the increase in fuel consumption, CO2 emissions increase. So with respect to the each and every feature we are looking. Yes. So finally, fuel consumption. Yeah. So here it is. So see, right. So this is about some analysis. Actually, we did not perform any pre-processing because the data is not having any outliers and no any values. And just we applied EDA, exploratory data analysis, statistical visualization. We will give things, what steps we need to discuss up to now. today we discuss automotive analysis with respect to EDA and data pre-processing. So it is second step discussion pre-processing. And we started with data types. These are the examples of various data types. And you can see first three comes under continuous data, and last two is nothing but discrete data. And we discussed about the measures of central tendency, mean, median, mode, and population sample. And mean is nothing but the middle value. It is also called as average. So median is nothing but middlemost value of the data set, and mode is nothing but the value which one is repeated. And dispersion is nothing but how the mean value is different from the data. Yeah. And why data? What is data process? It is a process of preparing the data and making it suitable for machine learning model. And why it is important, and why we need. So in real world data, contains noises, missing values, and unusable format data, and making it suitable for machine learning model. Yeah, these are the steps in data pre-processing, like getting the data, importing libraries, data sets, missing data, categorical data, etc. Okay, so this is EDA, and tomorrow we will discuss about unsupervised learning. And in